Hello and welcome to Algebra 2, Chapter 8.4, and today we are going to begin our journey on logarithmic functions. Okay, so first of all, just as a warm-up, what value of x works for 2 to the x equals 6? So, you might do some brainstorming about, well, I know 2 squared is 4. And I know 2 cubed is 8. So it has to be something between 2 and 3. And so, let's just guess here. Maybe because it's halfway between, maybe it's 2 to the 2.5. So I'm just going to use my calculator here. 2 to the 2.5 happens to be 5.656, etc. So that's not exactly it. So it's going to be higher than 2.5. And so you could sit here forever trying to find out exactly what value is going to get you exactly 6. And so we have to have some process of being able to figure out what does an exponent have to equal. And so this is where logarithms come in. And this is another operation, and it will help us solve for these exponents. So if we let b and y be positive numbers such that b is not equal to 0, then the logarithm of y with base b is denoted by log, so I'm reading this part right here, log base b of y, and is defined as follows. Okay, so this is really, really important. Log base b of y equals x if and only if b to the x equals y. Now, going off what we just were talking about, we just had 2 to the x equals 6. So if this is my b and this is my y based off of this right here, if and only if is a biconditional, which means you can go back the other way. So I could write this log base 2 of 6 equals x, and then I could solve for x if I knew what to do with this. And lucky for us, we're going to figure that part out. Alright, so the first thing we want to do is these are all in logarithmic form, okay, and you can tell that because they all have log. So log is the abbreviation for logarithmic. And you want to write them in exponential form. Okay, and so you really have to keep what you just wrote down handy. The fact that log base b of y equals x, then we have b to the x equals y. So this is my b, this is my y, this is my x, and you're writing in exponential form, which is with this exponent here. So 3 squared equals 9. And so you see then we get a true statement. Okay, what about the next one? 8 to the 0 equals 1. Again, a true statement. Okay, next, 5 to the negative second equals 1/25. And then we have 5 squared equals 25. Okay, so do you see how we can go back and forth between logarithmic form and exponential form? Alright, so we do have two special logarithm values, and that's when it equals 0 or equals 1. And that's because if this is your power over here, right, this number has to be 1 because anything to the 0 power is 1. Okay, and if this number is 1 over here, then this has to equal the same thing as the base was because anything to the first power is itself. So those are our two special logarithmic values. So next up, we're going to try to evaluate these expressions, and notice they're not equal to anything, but we're going to try to figure out what do they equal. So if you can at least just think about it as equal x, okay, what you're asking yourself here is 4 to what power equals 64? So I know 4 squared is 16. What's 4 cubed? There we go. 4 cubed is 64, so then that one equals 3. Okay. So this one wants to know 2 to what power equals, now I don't really want to write it as 0.125, okay? If you write that as a fraction, if I write this as 1/8, okay, so it did two things. It sent the number to the bottom, and the 2 became an 8, so it had to do what to the 2? It had to cube it, in which case we had to take 2 to the -3rd power. Okay, so let's try another one. So this one would be 1/4 to what power is 256. Okay, and so first of all, you should notice then that the number came back up. And 4 to what power is 256? It's to the 4th, but again, it needed to be a -4 because you did the reciprocal there. All right, so how about 32 to what power is 2? Okay, so now think of fraction exponents. Right, so what root of 32 equals 2? Should be the 5th root of 32 equals 2. And our last one here is 2 to what power is 1/28, and that's just taking 2 times itself how many times? And you're going to have to do 7 times. Okay, so at least make sure that you understand how to get those, and we can go back later if you want to and try to figure out exactly how we found out those numbers. All right, so we have 2 types of logarithms we see most often. We have ones that are base 10, so it would actually be log base 10 of something. And we call these the common logarithm, and so you can just abbreviate it as log, and so you can drop that base part. So anytime you see a log with no base, that means base 10. And we also have natural logarithms, which are base e. And so remember in 8.3 we talked about e. So if it's log base e, you abbreviate that just ln. Now both of these are on your calculator. If you have a graphing calculator, you're going to look on the left-hand side, and it is above the store button or below the squared button. So if I want to evaluate these, so notice none of these have a base. So this is the natural log, or sorry, the common log and the natural log. So in your calculators, you're just going to press log 7, and let's round to 3 decimal places. And so you should get 0.845. Try to make sure you can do this in your calculator. The next one, I'm going to press ln 0.25. And you should get -1.386. And the last one, ln 1.5, 0.405. So those come straight out of the calculator. Your calculator can only do the ones that are either common logarithms or natural logarithms. So the other bases your calculator can't do straight away. We're going to have to learn something else to do that. Alright, so one of the last things we're going to talk about in this video, and there is another 8.1 video by the way, or 8.4, sorry, is inverses of logarithms. Okay, and so let's consider g of x is log base b of x, and f of x is b to the x. And remember, if these are inverses of each other, okay, then that if we do both compositions, we should get x. Alright, I'd like to take a second and show you that these are inverses of each other. This will take a minute though, just bear with me. First of all, what we're going to need to do, let's make y equal b to the x, which is going to be our f of x there. We'll try and make an x again. And then let's go ahead and say that x equals log base b of y. And what I've done really, and I went ahead and I wrote it in here, is I've just used our rules. So I have not really assigned those other than they just came straight from the rules. So if we look at both of these, we're actually, let's say that y equals f of g of x. We're going to look at the second one first. And then remember that we plug in the middle term. So we have y equals, so g of x is going to be log base b of x. And then we're going to evaluate f. And where we see an x, we're going to put all of this. So this is going to be y equals, well, so here's what f is, so it's going to be b to that whole thing. All right. Well, so now that's written in exponential form. So that's up here on this side. And so I'm going to write it, take it from here and write it over into logarithmic form. So we have log base b of y, okay, equals x, which is our exponent, which is log base b of x. So if they both are log base b, it has to be that y equals x. So there's your x. So on the other one, if we have y equals g of f of x, and we're going to replace the middle one, so we have g of, so f of x is b to the x. So we're going to put this into g of x where we see an x. So this is going to become y equals log base b of b to the x. And so now that's written in log form. I'm going to write it in exponential form. So that becomes b to the y equals b to the x. And see if you can go through and make sure you know where I'm getting this from, because that's going to be helpful in your overall understanding of how these work. And so if I have the same base and they're equal to each other, then y has to equal x. And so that's how I know that they're inverses of each other. Alright, so we're going to simplify these, and it really kind of goes off the fact that I know that they're inverses of each other. And since it's on a different page, I'm going to go ahead and write down our inverses that we just had. We had log base b of b to the x equals x, and we had b to the log base b of x equals x. Alright, so this first one here, 10 to the, now if it's a log without a base, what's its base? Its base is 10. Remember, that was your common log. So this is really 10 log base 10 of x, and according to this second inverse here, if that base and that base line up, then my answer is just this x out here, so in this case it's just x. So for the next one, so notice on both of these inverses, you have this b that's in common in both places. Well, in this next one I don't necessarily have that, but what you can do, if this is log base 5, is there any way I can write 125 with a 5 instead of a 125? Well, that's 5 cubed. So this becomes 5 to the 3x. Alright, so now I'm on that first one, log base b of b to the x. So this is going to equal 3x. Okay. So this next one again, with a log without a base, it's going to be base 10. So this is going to be 10 to the log base 10 of 5x, which is just 5x. And our last one here, so this is log base 10. This is log base 10. So if I could somehow write this 10 to some power, so this is 10 to the 4x, which is then going to equal 4x. So this is really using those inverses to your advantage. Alright, so the next step here is to find the inverse. And so remember from chapter 7, to find the inverse, you just switch x and y. So we're going to start out doing the same thing. So we're going to have x equals log base 8 of y. But then remember, you have to solve for y. So this is in log form. We're going to switch over to exponential form, and we're going to go 8 to the x equals y. And that's just using that one rule to switch back to the other form. Okay, so on this next one, we're going to switch x and y. So we get x equals ln, so that's your natural log, y minus 3. So remember there's a base e here. So if I write this in exponential form, this is e to the x equals y minus 3, but I don't want it to be y minus 3, I just want it to be y. So if we add 3 to both sides, y equals e to the x plus 3. All right, that's what I got for you for the first half of 8.4. There is a second video on how to graph, but I didn't want to make them too long, so make sure you also watch the other video. And let me know if you have questions. This is very new, and so let me know if you have questions. So have a great day.